right, Lauren.
So number 19, how do you undo the cube?
How do you what? How do you
Like undo, like what's the opposite of cube?
Opposite.
It's like cubing, yeah, it's not including.
All right, let's look at number 19. Okay, 19 is f of x equals x cubed. Or y equals x cubed. Now, we're going to find the inverse of this. So
I didn't want to waste time getting up to throw it away, so
yeah, please don't throw things in the classroom. What's the first step to finding the inverse? Switch them. That's always the first step. So we're going to switch them. Now we have to get our y by itself. So what am I going to do to get y by itself? Cube root both sides. So y equals the cube root of x. There you go. That's your inverse. Lindsay. 21. The cube root of x plus 5. It's kind of the same sort of thing, backwards, I guess. Step 1, always the same, never changes no matter what. What's step 1? Switch your variables. Now, you got to get y by itself. It's underneath a radical. We're going to cube both sides. Absolutely. So x cubed equals y plus 5, because when you cube a cube root, they like cancel. So now we've got this, and all we have to do is subtract 5. There's your inverse. Anybody else have a homework question? Moses, what are you wearing today? Okay, what should you, is that what you should be wearing today?
yeah, that's all I
Oh, that's right, I'm sorry, you're right. I knew that, you told me already, you're right. Wear whatever you want, Moses, you're right on target, no problem. Sorry about that. What do you mean? I'm sorry. Any other questions about any of the homework problems?
I have a question. Yeah. How we did that. So you would never write, like, to get 5x minus a on the other side, you would never do 5x plus a?
Never.
Okay. Okay.
All right, get your note sheets out. We got a little learning to do today. Thanks for the little cheer there. That makes me feel good. I am actually starting to get pumped 2 weeks from today. You know what 2 weeks from today is? Plus, 2 weeks from today is the first mathlete day. Oh, cool.
Yeah.
Or Jamal, F is the best notation. So that would be the best way. All right. We are looking at problem number 4 on page 12. Problem number 4 on page 12. What we have here is a system of what are called parametric equations. Parametric equations. Now, they're easy to handle. There are applications, there are situations where we really like to have our equations written parametrically. That is separating x's and y, so x has its own equation and y has its own equation. There are other times we like to put them together and have one equation with x and y in it. So today we're just going to learn how to deal with these guys. So the first one is real simple. It says find an ordered pair, x and y, if you let t be 1. Well, what do you think you're going to do?
Put 1 in.
You're going to put 1 in for t. And if you put 1 in for t, do you see how you'll get an x value? What do you get if you put 1 in?
3.
No, yeah.
3.
3. So your x is 3. Now how are we going to get y? We're going to put 1 in here, and the y is -3. That's all there is to this first part. Let's look at the second one.
How do you know what to put in?
It tells you in the problem suite. The problem tells you. It says for t equals 1. Now, what does the second one say? What am I going to put in the second one?
7.
I'm going to put in 7. So what do I get when I put in 7?
4. Square root of 2.
I get the square root of 4, which is 2. And then when I put in 7 for y, or for 2 in the y equation, I get 49. Now, could we get a whole bunch of points for each one of these sets of equations? Could we get a whole bunch of points by picking different t values? Like we let t be 1 here, could we let t be 2 or 3 or 4 or 5? And every one of those t values would give us a point. And if we plotted all those points, we could get a picture of this, couldn't we? That's how you graph these things. You just pick all kinds of values for t, get all kinds of points, plot it, and connect the dots. But luckily you don't have to do that. Look what you have to do in number 5. Number 5 says, okay, we have this system of equations. And I don't want 2 equations though. Look at the directions. Find the direct algebraic relationship between x and y. That simply means write one equation that has just x's and y's. So somehow we have to combine these two into one. Does anyone have a thought on how to do that? Believe it or not, you already know how. You've kind of done this sort of thing before. It didn't quite look like this, but you've done it before. You have an idea?
Is it where like you put it like y equals -2 into the t?
Oh, she's talking about substitution. Now let's look at this for a minute. Let's take a look at the second equation. What does t equal? In this equation, what does t equal? Be careful.
Y minus 2.
What does t equal? Y divided by -2? If I get the t alone, I would divide by -2. Now, this is what t equals. What do you think I'm going to do with that now? I'm going to go back up to my top equation and see this t right here? What am I going to put in its place? Y minus 2? So my equation will look like x equals y divided by -2. My equation will look like x equals 3 times y divided by -2 plus 1. So x equals, okay, now this is 3 over 1, so what is that going to look like when I times that together? 3y over -2 plus 1. Now, how many equations do I have here? 1. What are the variables in that equation? Just x and y. You have done what it says. That's it. So you took 2 equations and you made them 1. Let's practice another one.
Wait.
Uh-huh.
Do you always use y to find t?
Use whichever one is easiest. So if I look at the next equation, Erica, the next set, I want to get a t by itself. Which one would be the easiest t to get by itself? The top one this time. Now, could I do the bottom one? Yeah, but it's just going to be harder. So if I do the top one, then x minus 4 equals t. Everybody okay with that? Now, what am I going to do with this x minus 4?
Times it by 7.
I'm going to put it right here, right?
Yeah.
So what's that equation going to say? Y equals 7 parentheses x minus 4 minus 3. So y equals 7x minus 28 minus 3, or 7x minus 31. And that, you're done. You took these 2 equations and you did some substitution and you ended up with one equation with no t's, just x's and y's. A little harder because there's really no easy t to get. So I don't care which one you want to go with. The bottom one? All right, we can go with the bottom one. Sorry. It's okay. I listen to Lexi. Okay, so we're going to go to the bottom one. So we're going to get t by itself. All right, so here you go. How are we going to get t by itself? We're going to have to add 1. And then we're going to have to divide by 3. Is everybody okay with that first step? Now, this is what t equals. So I'm going to go up to my top equation, right? And I'm going to take out the t, and I'm going to put this in its place. So what is that top equation going to look like? X equals 2 parentheses y plus 1 over 3 plus 4. Now this is 2 over 1, so what's that going to equal? 2y plus 2 over 3 plus 4. Now you can stop right there if you want.
Why is it?
What?
Why don't you use? Oh.
Okay, I got a practice quiz here for you. Over inverses. Tonight you'll practice some parametric stuff. Take a look at this. This is what you do, Angel.
Run down the back rules.
I'm sorry.
Write down the what?
The rules for this.
we're doing the side that says inverses. We're not quite ready for the other side, although we are going to begin that later today. All right, but let's do this practice side first. Okay, here we go. F of x equals 4x minus 7 over 3. Our job is to find the inverse. Okay? Now you know how to do that. This one you could actually do in your head. It's easier. But let's go through the steps for those of you that like to do it with the steps. Those of you that do it in your head, go ahead and write your answer down and see if it's what we end up with. What's step one if we're doing it officially? Switch the variables. Now we got to get that y by itself. We're doing an inverse now, kids. So we're going to multiply by 3. And then what happens next? What happens next? No. I want to get y by itself. So I need to add 7. And then I need to divide by 4. So our inverse is 3x plus 7 over 4. Remember, that's your inverse notation. Now, does that answer make sense? Yes. Because what does the original function do? It multiplies by 4, subtracts 7, divides by 3. Now undo that. You would times by 3, add 7, divide by 4. Anybody have a question about that problem? It's easier than the ones we did earlier. Number 2, given this thing is drawn, would you say it's 1-to-1?
Yes.
Yes, why? It passes the vertical line test and the horizontal line test. Remember, that's your rule. It has to pass both. Do you remember from yesterday how to sketch the inverse of a picture? How do we do that? Flip the points. So let's try to be organized because you got to connect them in the right order. If I start as far as I can to the left, if I start with my leftmost point, what is that point? -4, 0. So I will plot that first point at 0, -4. Does everybody remember this from yesterday? Okay, the next one is at -3, -3.
Yeah.
Doesn't it just stay there? The next one on the graph is at -2, 0, so I'll plot it at 0, -2. Now, 6th period yesterday, they were having a little trouble keeping the points straight. So if you want to connect them as you go, then you won't be confused about the shape. -1, 1 will be 1, -1, and 0, 0. So there's the first part of the picture. Does that look what yours looks like? Right now I'm doing 1, 2 would be 2, 1. And 1, 2, 3, 2 would be 2, 3. 1, 2, 3, 4 would be. How do you feel about that? How do you feel about this quiz? You feel okay about it? Any question about it? So if we wait 23 hours, we're still gonna be okay? All right. Get your note sheets back out then. Get excited, we're gonna do some graphing. Woo. Turn the page, we're on the next page of your note sheet. And the whole first part of this is review. The second part adds a little bit of a twist, but the whole first part, number 1A, is review. What shape is x squared? A parabola. What impact does the -3 have? Down 3. So when you sketch that, you're just going to sketch a nice little parabola like that. Old news, right? What about B? Same parabola, but what happened now with that -3?
To the right.
Moves to the right 3. Because as we have discussed a lot, where the 3 is important. If it's outside, it moves you up and down. If it's grouped with the x, it moves you sideways. C. What do you think about C? Left 1, down 2. Everybody okay with that? All right, now, part 2 deals with negatives. Now, we've already talked about the negatives, like in number A, or letter A. What shape is an absolute value? It's a V. So the normal shape will look like that. What does putting a negative out in front of the equation turns you upside down? So your V is going to just be flipped over. This negative turns you upside down. Moses, we call that a reflection across the x-axis. We move it across the x-axis. So when you're making your rules, I use the word upside down, which is fine, but if you want to talk formally, it's a reflection across the x-axis. All right, how about B? What does e to the x look like? What's the basic curve? E to the x. Uh-oh, we can't forget our BFFs, folks. E to the x looks like this. That's your exponential. What does this negative here do? Turns it upside down. So if we turn that upside down, can you see your picture is going to look like that? It just turns it upside down. Now Miss Ford got wild and wacky. What's going on here? Exactly. Notice that the negative is not on the whole thing, it's just on the x. When you put the negative on the x, you reflect across the y-axis. So instead of flipping this way, it flips this way. So remember, this was your original. If we flip it this way, would you agree that it's going to look like this? put the negative is important. If the negative is out in front of the problem, it turns you upside down. If the negative is inside the problem on the x, then it flips you sideways.
That's only.
So look at problem D. Is this guy flipping upside down, or is he flipping this way? Look at where the negative is. That's upside down. The whole thing's negative. So that's going to flip upside down. What else is it going to do? It's a parabola. It's going to move which way? Left one and be upside down. Why is it going left one? Because it's x plus 1 grouped. Uh-oh, look at the next one. Which way is number E flipping?
Across the line.
Across the y-axis. Now, before I do that, what does an ln look like? Y equals ln x. That's one of your BFFs. It looks like this. Now, we are going to reflect that this way. So do you see that it's going to look like this? If you fold it across the paper. How about F? How is F flipping? Upside down. This was E. Now, this is the shape, but we're going to flip it upside down. So it's going to look like this. Would you agree with that? If I turn this upside down? Okay. So let's recap. A negative out in front of the problem does what? Upside down. A negative on the x, just on the x, flips you left and right, sideways. Got it? Okay, we're going to do a couple more and then we'll be done, okay? Look at problem 3. I'm going to give you some graph paper. Because I don't want you doing it in your note sheet, so I want you doing it on graph paper.
Graph papers. I'm so excited with graph, guys.
You look excited.
3 days. I'll let you look
Okay, everybody's got a couple sheets of paper now. So here's what I want you to do. have been given this weird random shape. This is the shape that you are going to use for all of the problems in this particular set. Okay? Oops, I didn't connect everything. Alright, so that's the weird shape that we're using. This is the function f of x. Now, look at problem A. I promise, we're going to do 2 of these and then we'll be done, okay? But hang with me while we do these 2. Look at problem A. Where is the negative? Outside. It's not on the x. It's not grouped with the x. It's on the outside. What happens when you put the negative on the outside? It flips it upside down. So on your graph paper, I want you to take every point and flip it upside down. Now, you guys, if the point is on the x-axis, it's just going to stay there. But see this point? He's down 2. If you flip him upside down, where are you going to put him? Up 2.
Do you do the opposite of the y?
Yes. It changes the sign on y. You're going from up to down and down to up. So if it's on the x-axis, it stays the same. Now see this guy? He's 1 up, so he's going to have to go 1 down. You're turning him upside down. This guy's 2 up, so he's going to have to go 2 down. He's 1 down, so he's going 1 up. And there's your picture. Turned upside down.
Amazing.
We're going to do 1 more, then we're done. Okay, so this is negative f of x. This is problem A. Does anybody have a question about that? That's the original. This is problem A. Everybody good? All right, now let's look at problem B. Same original, but now look where the negative is. It's grouped with the x, which means it doesn't go upside down, it goes this way. So look at this point. I like to do this organized, so I'll go point at a time. See this point? He's 1, 2, 3 units to the left. If I'm flipping everything this way, then that point's going to be 1, 2, 3 units to the right. Would you agree with me? And this next point is 1 unit to the left. He's now going to be 1 unit to the right. This point right here. He's 1 unit to the left. Now he's going to be 1 unit to the right. The origin isn't moving, right? The origin doesn't move. So here's the first part of the picture. See that V right there? That V? If we flip this way, doesn't it make sense that that V is going to end up right here? Now, what's going to happen to that point? He's up 1, right 1. Well, he's going to have to go up 1, left 1. This guy is right 2. So he's just going to go left 2. And there's that little V. Now, where's this point? 1, 2, he's right 3, up 2. Now he's got to go left 3, up 2. This guy's right 4, so he's going to go left 4. promise, if you notice, there's a ton of practice. We're gonna do a lot of practice with this. But that's enough for today. Your homework tonight is a bit of parametrics, so you'll practice that. I also anticipate a quiz tomorrow over what? Inverses. Okay, so we got 3 things going on here. Homework is over parametrics, that's the T stuff. Inverses, what we talked about yesterday, review today, and then we'll continue the graphing. Everybody good? Yes.